Today is 0, 5 adding probabilities. So if yours got cut off and that bothers you, write 0, 5 at the top. There's a couple of things we're going to put on the back that you might end up needing, but we'll do that in a second, okay? So today is probability. You guys have heard before, what is the probability of flipping tails on a coin, right? So what is the probability of flipping tails on a coin? 50% or 1/2, same thing, right? So it's 1 to 2, okay? The reason for that is, if you look up here, probability, the chance that a given event, E, will occur. So the probability of flipping a tail is the number of favorable outcomes, the number of tails on a coin, in this example, over the number of possible outcomes. Well, there's one tail out of two sides, so it's 1 out of 2. Does that make sense? I'm going to jump down to odds really quickly. Odds is the same idea, but it's not the same answer. So odds is successes to failures. If I wanted to know the odds of flipping a tails on a coin, it would be 1 to 1. Do you get the difference? So probability is however many things there are out of the total, 1 to 2, for tails on a coin. Odds is however many things there are, however much is left, 1 to 1. So, for example, I'll give you a different one. Die, that's one dice, right? Die, if I wanted to know the probability of getting a 3 on a die, how many 3s are on a die? 1 out of 6. That's probability. Odds would be 1 to 5 is left over. Do you get the difference? The idea is the same, but the answers are not. Okay? And we'll get to some practice in a minute. Simple event is only a single outcome is possible. So for example, both things I just told you, the probability of a tail on a coin, or the probability of a 3 on a die. That's a simple event. Okay? Compound event is 2 or more simple events together. For example, what is the probability, I'll use cards this time. What is the probability of getting an ace or a spade? Getting an ace is a simple event, getting a spade is a simple event, and I'm shoving the two together. Do you get what I'm saying? So it's more than one thing shoved together. Mutually exclusive and inclusive events. Have you ever heard someone say that these two things are not mutually exclusive? Have you ever heard that? Okay, well, people say it. So mutually exclusive, two events that cannot occur at the same time. For example, I'm going to talk about cards again. Okay, you guys know enough about cards to know like there's 4 suits and the red and the. We'll get there if you don't know what I'm saying. So for example, when we're doing exclusive, can you have a heart and a spade on the same card? No, those are exclusive, right? Can you have a jack and a heart on the same card? A jack of hearts. Yes, that would be inclusive. Do you get the difference between the two? Okay, so mutually exclusive has its own equation. So if you're saying probability of this or that, you take the two probabilities and add them together. Inclusive is saying the probability of this thing or that thing. You do what I just said. You add the two together and you subtract out the probability of them both happening at the same time. And I'll show you an example in a second. Okay, and then we already said odds. So before we actually get started, I find that the longer I teach, the less kids know about cards. So let's go on the back and write what we know about a deck of cards, okay? So go to the back side. Well, there we go. So I'm going to write playing cards. Even if you don't think you need this information, it's kind of helpful to have just so you don't have to think about it every single time, okay? So a standard deck of playing cards is your ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Everybody okay with that? How many cards is that? Not not just right here. 13, right? 13 cards. And then you have your suits. You have 4 suits. You've got your red ones, your heart and your diamond. And the black suits, which are spade and club. So sometimes they'll want to know the odds of a red card or a black card or something. So I kind of list them that way. So how many cards are total in a deck then? 52. I haven't said anything crazy, right? Are you guys okay? Did you And then I don't know if we need this one today or not, but we're going to do dice as well. Even if we don't use it today, the other notes that we might need it on won't have space, so let's just go ahead and put it on here. I can't remember if you need it in your homework or not. So for dice, we're going to roll 2 dice, okay? So that's going to be 6 choices in one and 6 in the other. So we're going to draw a 6 by 6, I guess you could call it diagram maybe? So 1, 2, 3, 4, 5, and that would make 6. 1, 2, 3, 4, 5, and that would make 6. So we have 1, 2, 3, 4, 5, 6 on like a red die or something, and 1, 2, 3, 4, 5, 6 on a blue die or something like that. We have 2 different die with 1 through 6 in each of them. Okay? So some questions, whether it's today or tomorrow, I don't remember, some questions are going to say, what's the probability of a sum of 5 on 2 different dice? Okay, so this chart is going to help us find those answers a lot quicker than if we had to think about it over and over and over again. Okay, so if I have a 1 and a 1, what is the sum that I've rolled? 2, and then 3, 4, 5, 6, 7. Do you guys get that? Inside the boxes is their sum. Okay, what would this one be? 5, 6, 7, 8. So I'm going to go down this way too. It's 4, 5, 6, 7, and you just keep going. So the 4 is now 5, 6, 7, 8, 9. I don't think you need my help, so go ahead and keep filling that in, and you can check it with mine. Obviously, I assume you've noticed a pattern by now. They just go up 1 every time, right? So go ahead and fill that in, check it with mine, make sure you didn't mess that up. All the diagonals should have matching numbers. See how this is a 2, 3, 4, 5, 6, 7. You see all those diagonals? If that doesn't match up, you did something wrong, okay? So again, even though they may not ask you today, if they say, what's the probability of rolling a sum of 4 on 2 dice? So I can just look here really quickly and be like, okay, how many times can I roll a sum of 4 on 2 dice? 3 out of, if I said probability, how many total is this, by the way? 36, right? So it'd be 3 out of 36, which you always reduce to 1 out of 12. Right? Anybody confused? Okay, again, I don't remember if you need that today or not, but I'd rather go ahead and get it out of the way. We ready for the front? Whoa. Okay. Number 3. Determine whether the events are mutually exclusive or mutually inclusive, then find the probability. So you have to find out whether they're exclusive or inclusive to know what formula to use anyway. You kind of have to do that for yourself. Number 3, a card is drawn at random from a standard deck of cards. Letter A, probability of a club or a diamond. Question 1, can you have a club of diamonds? Can you have a diamond, what did I just say? Can you have a diamond and a club on the same card? No. So is that inclusive or exclusive? Exclusive. So that's mutually exclusive. I'm just going to write ME for right now. You can do whatever you want, but I don't have a whole lot of room. So because it's exclusive, it's this formula right here, where you take the probability of each of those separately and you just add them together. So I'm going to do the probability of a club plus the probability of a diamond. How many clubs are in a deck of cards? 13, right? Out of what? 52. How many diamonds are in a deck of cards? 13 out of 52. 13 and 13 is 26. What's 26 out of 52? 1/2. Half the deck is a club or a diamond. That makes sense, right? Did I lose anybody? Okay. Letter B. Ace or spade. Can I have an ace of spades? Yes, I can. So is that exclusive or inclusive? Inclusive. So that's going to be this one. So I'm going to write INCL on top of it because I don't have a lot of room. So that means you take the probability of each separately like we just did, and subtract the probability of both of them happening at the same time. And I'll show you what I mean. So probability of an ace plus probability of a spade minus the probability of an ace of spades. That's not multiplication, it's an ace of spades, if that makes sense. How many aces are in the deck? 4 out of 52. How many spades are in the deck? 13 out of 52. How many ace of spades are in the deck? 1 out of 52. Did anyone get confused as to where those numbers came from? Go ahead and add that together, or combine it, I guess. And what do you get? Use a calculator, reduce. What do you have? Yeah, so reduce it. Yeah. What is it, guys? 4 out of 13. Everybody do it. Get it right. You always reduce, right? 4 out of 13. Here's why the formula is what it is, okay? If you're a formula person, just do it and it's fine. The reason why we do it that way is if I am taking the aces, okay, all the aces, that includes the ace of spades in it, right? And then if I'm taking all the spades, that also includes that same ace of spades in it. How many ace of spades are really in a deck, though? 1, but I've acted as though I have it twice, right? So I had to take one of them out. Does that make sense to you? I include the ace of spades here, I included it here, but there's really only one of them, so I need to take one back out. I counted it too many times. That's why you subtract one out.
Why is it easier to get a spade period than it is to get an ace?
Because there's more spades. Okay. All right, so jack or a red card. First of all, can you have a red jack? Yes, so inclusive, right? So we have to find probability of a jack plus probability of a red minus probability of a red jack, or however you want to write that, okay? How many jacks are in the deck? How many jacks are in the deck? There's one of each suit, so 4, right? 4 out of 52. How many red cards are in the deck? 26 out of 52. How many red jacks are in the deck? 2, the heart and the diamond, right? So use your calculator. I mean, I guess you don't have to, but you can. And what do you get? Yeah, you should get 7 out of 13. If you don't, ask a question. Have I lost anybody? You guys okay? Pretty easy? Okay. These can get very tricky, but like I said, we're just kind of skimming the surface, so it shouldn't get too hard for us yet. All right. Number 5, there are 40 vehicles on a lot. There's 40 cars in the parking lot, okay? All of them are either sedans or SUVs. Those are your only 2 choices. There's 18 red ones. 3 of those are sedans. There's 15 blue ones. 9 of them are SUVs. And the rest of them are black, and 2 of those are SUVs. So they just gave me some information about cars, okay? So they want to know the probability of a blue or a black one. So the way that they gave us the information is not helpful for me finding answers. I want to kind of make a list like I did on the back. So I'm going to go ahead and start with how many red cars are there? 18 red ones. How many, I did blue next. 15. How many black ones? You have to think about that one. You can't just look at it. There's 18 red, 15 blue. How many total? 40. So how many black would that leave? 7. Do you guys get what I'm doing here? That's easier for me to kind of like keep it together. Okay? You could do more than that, but I'm going to do more if I need to later. So, blue or black? First of all, can you have a blue-black car in this parking lot? No, right? So these are exclusive, mutually exclusive. I think we still have to say that, so I'm going to put ME above it. Okay? So that means find the probability of a blue one and add the probability of a black one. How many blue ones are there? 15 out of 40. How many black ones? 7 out of 40. And then add those together. Use your calculator, reduce. What do you get? 11 over 20. Anybody not getting that and need some help? Are you sure? Okay. Probability of a red or an SUV. Is that inclusive or exclusive? Inclusive. You can have a red SUV, right? So I'm going to take the probability of a red car, add the probability of an SUV, and subtract out the probability of a red SUV, if that makes sense. How many red cars are there? 18 out of 40. How many SUVs are there? We don't know right ahead, right? We have to kind of look at it. So let's go back. They told us there's 3 of the 18 red ones are sedans. So how many SUVs would that be? 15 SUVs in the red, okay? And then 9 SUVs in the blue, and then 2 SUVs in the black. So it's 15 plus the 9 plus the 2. 26 out of 40. Minus how many red SUVs are there? 15 out of 40. And what's that give us? 29 out of 40. Yeah, it doesn't reduce. 29 out of 40. Anybody confused? Okay. This last one, can you have a black sedan? Yes, you can. So that's inclusive. Oh, I didn't write exclusive here. Oh, that's inclusive. Just kidding. This one was inclusive. This one was inclusive. If they asked, I don't know if that's still the directions or not. So we need to find the probability of a black car, add the probability of a sedan, subtract the probability of a black sedan. You don't have to write this. Obviously, I'm trying to squeeze it in. How many black cars are there? 7 out of 40. How many, what is it, sedans? How many sedans are there? 14 out of 40. How many black sedans are there? 5 out of 40. If anyone's confused as to where those numbers came from, let me know. And what do you end up with? 2/5 is what I'm getting. Take your time and get 2 over 5. Ask a question if it's not working for you. Anybody confused? Okay, great. This last question, I'm going to leave a little bit more room. 2 fair coins are tossed. When they say a fair coin, there's multiple reasons they say that. All they're saying is like it's not a magic coin, so it's not like weighted one way or another. It's not like tails on both sides. It's an actual like regular coin out of your pocket. Okay, 2 fair coins are tossed. Find the odds in favor. So they said odds this time. We're so used to probability that you need to pay attention to that. Okay. They said find the odds in favor of both landing on heads, then find the odds in favor of exactly one landing on tails. So it's 2 questions in the same question. I'm going to go ahead and do a tree diagram because it's not that hard to do on this question since they're just flipping a coin twice. So the first time you flip a coin, it's either heads or tails. Well, that's easy, right? The second time you flip it, heads, tails, heads, oops, tails. So here's my sample space. You got heads twice, you got head tail, you got tail head, or you got tail tail. That is my sample space. 4 choices, right? Find the odds in favor of both landing on heads. How many have both H's? 1. So both heads. 1. They said odds. So what's the odds of it not happening? 3. Probability would have been 1 out of 4. Odds is 1 out of what's left. If there's 4 total, there's 3 ways that it won't happen. There's 1 way it will happen. There's 3 failures. 1 success, 3 failures. The next one was exactly 1 tail. How many have 1 tail in them? 2 of them. How many are left? 2. Reduce. 1 to 1. Odds is a ratio. It's still a fraction, so you still need to reduce it. Ask me a question. Are you sure? Pretty easy? All right. Go ahead and get started. Let me know what you need. It's P15, right? Not page 15. It's P15, 2 to 8 even. I know the answers are in the binder. I'm not sure if the work is or not. I kind of feel like it shouldn't be, but I think it is. So let me know what you need.